Okay, for this video, we'll be going through DC circuit tutorial 2. Okay, question 1, it shows a DC circuit. We see that there's a 12 volt battery, R1 4 ohm, R2 6 ohm, and then we have a switch here which is open. Then we have R3 8 ohm. So they are actually all connected in series. Okay. So on figure 1.1 indicate the direction of the conventional current. So this is the kind of questions that I'd like to warn you about, because sometimes there's no space for you to write anything. You may miss out this question, and this can be easily 1 mark. But in O level, there will actually be a mark inside a bracket. So do look out for all this. So conventional current always comes out from positive and enters the negative. So it's good to label your direction of the current on the wire itself. Okay, B, when switch S is open, calculate the effective resistance of the 3 resistors. So if switch S is open, there will not be any current flowing through it. So the current will be flowing through all 3. So the effective resistance for series will just be, you add them up. Now the current drawn from the battery while switch S is still open, right? So therefore, we can actually redraw this 12 volts into one single resistor. So you'll get 0.67 ampere. Now the current flowing through R3 will also be the same as the total current that comes out, because in series the total current is the same. Now the potential difference across R2, so take note they're asking for R2, so the current flowing through is 0.67 ampere. We have the resistance of 6 ohms, so the V will just be 4 volts. Or I can actually use my the potential divider formula. Okay, so we take the resistance 6 ohm over the total resistance multiplied by the voltage that's available. So you'll get the same value of 4 volts. Now when switch S is closed, calculate the current drawn from the battery. Now switch S actually has no resistance, therefore it forms a short circuit. Okay, that means 8 ohm will be bypassed. Therefore, the total effective resistance will just be 4 plus 6 ohm. So I will have a 10 ohm, so 12 volts. So the current that comes out will be 1.2 ampere. Okay. Then the potential difference across R2, you repeat V equals to IR, because the current flowing in series is the same through every resistor. Okay. Yeah. So let's go to question 2. What's the effective resistance between X and Y? So X and Y, we have actually I will just draw X and Y out. It will actually form a 12 ohm. How do I get 12 ohm? Because 2 and 10 is parallel. Is in series, so I can add them up. So this is parallel to 6 ohm. And then if I apply the parallel formula, 1 over REFF equals to 1 over 12 plus 1 over 6. I'll get 1 over REFF equals to 3 over 12. Therefore, REFF equals to 4 ohm. I'm doing this so that you all remember that you need to flip. And the way that you represent the answer is important, because some of you will not do anything here. You'll just do your working like that, and it's very weird, because 3 over 12, it is not equals to 4 ohm. Okay. So now they're asking what's the current flowing through R4. R4, because after we have resolved this, we can actually redraw the circuit. 24 volts, which is the battery. Then over here, we actually have 4 ohm. We actually have 8 ohms. Okay, so this is where this whole thing becomes 4 ohm, right? And I can actually redraw it further to have 24 volts and 12 ohm. Okay, so the current flowing through will be 2 ampere. Okay, so that's the current flowing through R4. So what's the potential difference across R4? It will just be 2 ampere multiplied by 8. It will be 16 volts. Okay. Now what's the potential difference between X and Y? So if over here it is 16 volts, then over here, which is X and Y, it will be 8 volts. Because in series, remember X and Y, we actually found them to be equivalent resistance of 4 ohm. So in series, the voltage is the sum of the total EMF. So if across R4 is 16 volts, therefore I'm left with 8 volts. So the potential difference is 8 volts. Now what's the current flowing through R2? So do you see that the question is actually helping you the voltage across here is 8 volts, right? They're asking for the current flowing through R2. Where's R2? R2 is over here. R2 is at the top branch. Remember just now I did this parallel, I pulled it out. So if across the 12 ohm and the 6 ohm is 8 volts, I can actually calculate the current flowing through the 12 ohm, because the potential difference across 12 ohm is 8 volts. So the current flowing through is 8 divided by 12 equals to 3 over 4 equals to 0.75 ampere. But are they asking for the current? 8 divided by 12 on. Okay, I'm sorry. It is 8 over 12, is it? Eight over 12. It's actually not 3/4. My mental sum. It is actually common factor is 4, so it's 2/3. So equals to 0.67 ampere. Okay, so it's not 3/4, right? Then what's the potential difference across R2? We'll just apply our V equals IR. You should get 6.7 volts. Okay. So this is the voltage divider rule or the potential divider. Current divider, it is not applicable in our syllabus, but you can learn it also. It is for 2 parallel path only, so it's not very useful lah. Okay, the voltage divider and your V equals IR and your way how to resolve all your resistance and your sum, sum, all these are more important. Yeah. Okay, now figure 4.1 shows a circuit. The battery and ammeter have negligible internal resistance. That means we treat them as no resistance at all. So we see that this is a battery is 6 volt. We have 8 ohm and 12 ohm in parallel. Then we have a resistor of R. When the switch is open, okay, the voltmeter reads 4.2. That means over here is 4.2 volts. Okay, so if switch S is open, it means that there is no current flowing through the 8 ohm. So effectively, I can draw it like that. Okay, 12 ohm, and then we have R, right, 6 volts. So the voltmeter actually reads 4.2 volts. Okay, which means the potential difference across the 12 ohm is 4.2 volts. Okay, so if the voltage across the 12 ohm is 4.2, which means the voltage across the R will be 1.8, because they must sum up to become 6 volts. This is for when resistors are in series, the sum of their potential difference is equals to the EMF. So with this, I can find my voltage across R to be 1.8. And because I know the voltage across 12 ohm, so I can actually calculate current. So equals to 4.2 divided by 12. Okay, and it's equals to 0.35 ampere. And because they are connected in series, therefore, the current that flows through resistor R is also 0.35 ampere. And because I know their voltage, so I can actually use V equals to IR. R equals to V over I equals to 1.8 volts over 0.35 ampere. So I'll get 5.1 ohm. Okay, or I can apply the potential divider formula, because R1 over let's say R over the sum of 12 ohm and R multiplied by the available voltage will be equals to the EMF. Okay, hold on, I think there is something wrong with this. Oh, it's okay, it's okay. Yep, because they are using R1 as the 12 ohm. Okay, then since we now know the resistance of R, which is 5.1 ohm, which won't change because it's a fixed resistor, we can proceed to part B, which now the switch S is closed. So the equivalent circuit will then look like this. I have a 8 ohm here, I have a 12 ohm here. Just now the 8 ohm wasn't around, plus I have a 5.1 ohm here. Okay, so it's always good to do a very quick sketch of the new circuit. So they want us to find the reading of the ammeter and voltmeter. Now voltmeter is still across the 12 ohm and 8 ohm. My ammeter is here. Okay, so actually I can find the total resistance across X and Y, which is here. If we look at the answer, find X and Y, and because 8 ohm and 12 ohm are in parallel, I can actually resolve it to become 4.8 ohm using the parallel resistors formula. So I get 4.8 ohm here and 5.1 ohm here, right? Because I didn't do anything to it first. So I can then solve for the current. So again, effective resistance become 9.9 ohm. Okay, so you can actually solve to find the current flowing through, which is 0.6 ampere. Okay, and once I know the current flowing through 0.6 ampere, I need to find the reading on the voltmeter, and because their equivalent resistance is 4.8 ohm, the voltage across it will be 0.6 multiplied by 4.8, and I'll get 2.9 volts. Okay, or I can verify by using the current through the 5.1 ohm. I find the V equals to IR. I find the V 0.6 multiplied by 5.1, so I get a certain value. 6 minus this value, I should get 2.9 volts. Okay, so actually DC circuit, there are many ways to solve the question.